Thank you everyone for coming. As Marcel said, my name is Kacper, and I'm going to discuss various problems with inversion of control. I'm going to also discuss what inversion of control is and what it isn't. And I'm going to show you how we can look at it from different perspectives. So that's my Twitter handle. If you want to follow me on Twitter, I'm technical team leader at SymfonyLive UK. I'm also a trainer from time to time. I'm a Symfony certified developer, and I also co-founded the PHP meetups in Poland. So that's about me. And this talk is split into three chapters. And the first chapter is about the theory of inversion of control. And just on the very beginning, I would like to say one thing, that this is not yet another dependency injection talk. I'm not going to talk about constructor injections and why you should do this and why you shouldn't, and when you should use setters and so on. I'm not going to cover the basic stuff. Obviously, I'm going to talk about it, but from different perspective a bit. So, because of that, we need a bit of clarification. And the first thing that I want to clarify is that inversion of control is not just dependency injection. Why? It's because inversion of control, according to the definition, is a design pattern that addresses a component's dependency resolution, configuration, and life cycle. It suggests that the control of those three should not be the concern of the component itself. So it just says that our code shouldn't really care about its dependencies, and it shouldn't care how they are instantiated, what's the life cycle, and so on. We shouldn't care about it, really. And dependency injection is one of its incarnations. So in dependency injections, we say, OK, all our dependencies are given by a constructor, by some methods, or by field injection. So the difference is that inversion of control is the general big concept that says we shouldn't care about it. Dependency injection is the way of solving that problem. And there are other ways of solving that problem. And there are actually three. So one is dependency injection, as we say. The other is AOP, and the third one are events. And I'm going to say in a second why I think these are the three ways of solving that problem. But first, in the very beginning, I would like to say, why do we invert this control of our applications? And what are the pros? Just quickly, we know all that. So we don't want to care about the dependency resolution, configuration, and so on. We want to enforce the single responsibility principle, which says it's not that object or method or class has one responsibility. It has one reason to change. And what's important, if we are writing our code and the way that some other object is created is changing, and we have to change it in our code, it means we have two responsibilities, because we are doing our thing and we are changing how the other object is created. So there are two responsibilities, and we want to get rid of that, basically. We also want easier testing, and it's doing things right with inversion of control enables that, but not always. I'm going to show why. And also we want to promote the modular architecture, loose coupling, and all these good things. But what are the downsides? What are the cons of this approach? Obviously, there is a learning curve, especially for new developers. But we can handle that. We're smart guys. But what's worse, the code becomes harder to analyze. Small units are OK, are fine, but our code is not longer linear. It's not procedural. We can just print one page and read what's happening there, especially if we are using events. So the inversion of control moves this complexity from our module somewhere else, but it doesn't remove it, and it has to be solved in some ways. So we have like extra tools like containers, dispatchers, and so on. So just to remind you, how do you write software without inversion of control? So we've got some simple interface that erases the files. We've got a logger that just echoes, prints, whatever. And then we have our class. So whenever we need the logger, we create an instance, we log, which prints, we unlink the file, that's the example, and that's it. And then we use it in this way. We all know that. So these are the basics. And with dependency injection, it's quite obvious that we are probably going to use constructor injection, then create this dependency outside, and it's done. It works in this way. And if you think about it, if you look at this code, what's happening here, our module, our class, we are in control what is being executed and when this thing is being executed. So we are in full control, and if you look at the chart, it gives us in this position. So we know the what and when are known. And that's one of the approaches to doing the inversion of control. So we are in control of everything. Obviously, it adds some complexity to our code, but it also gives us the benefit that we can change it whenever we want it. So how we can solve the same problem with events? So again, I created a really simple implementation of observer. So we have just some listeners, some event. Then we have some file event. Something is happening with a file. Then just extension of this. Then we have a logging file event listener. So it gets the logger, and when there is a file event happening here, it just logs this. So it basically does this exactly the same thing. And then there is a dispatcher. It's not important. But what's important in our case here is that our file eraser does exactly the same thing, just unlinks the file, but it doesn't really care how this logging is handled. It decides when this thing is handled, so it dispatches the event. So it says, hey, I'm going to do this, but it doesn't do anything about it. It's not aware that there is some logging happening. And then, again, there is another event dispatched. And we instantiate it, configure the dispatcher, and that's it. So on this chart, it positions us here, that we know that something is being executed, and we are in control when this thing is being executed, because it's our class that's responsible for sending these events, emitting these events, but we don't know what's happening. So that's like this that's exactly the same problem solved in two different ways that are giving us two different levels of control of our dependencies. So also there is a third thing, which is AOP, aspect-oriented programming. And I know that in PHP there is a thing called Go AOP PHP, which is like AOP container. But I'm not going to use it because it's going to be too complicated, and I don't really like the idea itself. I'm just talking about it for the sake of being covering the topic in 100%. So what we really want to do, what's ultimate responsibility of our class, is to unlink the file here. And that's the purest form of our class. So what we can do with AOP is to implement it using DECORATOR, so basically decorate it. And that's maybe an overstatement, but it is an implementation of AOP. So we have our file eraser here. We are injecting, decorating it, and adding aspect before. Okay, logger. File eraser was initialized, then calling the decorated logger, and then adding another aspect after. Also, we could add a try-catch here and add some other aspects as is described in AOP. But that's the implementation. And then we just create this local file eraser, then the logging file eraser, and call one after another. It's just decorated inside. And what it gives us here on our chart with AOP, from our class point of view, we don't know that something is happening. We don't know when this thing is happening. So we are not in control of anything. We can just do our thing well. So that's the way of solving exactly the same problem and having dependencies as well. So having the complete chart here is that with DI, you know what and when. With events, you know when, but you don't know what's happening. And with AOP, you don't really care. OK. And also in the abstract, I promised that I'm going to explain what's the difference between a framework and a library from the IOC point of view. So a library is a simple thing that provides you with some functionality. You get it, you call it, you have the result, and you don't care anymore. So the library is something that gives you, and you are just using, gives you some functionality, and you are just using it. If you think about frameworks, frameworks provide you architecture in which you structure your code. You configure these frameworks, for example, in Symfony, you configure the routing, the controllers, and so on. But it's framework that is deciding when your code is going to be called, how the dependencies are going to be instantiated. So from your module point of view, you are not in control when you're going to be called. And it's called a Hollywood principle, which is don't call us, we'll call you. And if you think about it, in a sense, frameworks, at least some of them, utilize the IoC principles. So we can think about frameworks of being a form of inversion of control of your code, of the module that you are writing. Because you are just feeding the framework with some configuration and your code that's going to be executed. So that's it about the theory of inversion of control. Now let's have a look how we can actually solve it and why some ways of solving some common problems are not too good. So containers first. We know what containers are. Containers are just massive factories that creates all the dependencies for you. And where containers are good and when you should use containers, so they are good at resolving massive object graphs. So you have loads of dependencies, parameters and everything, and you basically don't want to care about it. You just want to get your dependencies. So if this thing is really big and this graph is becoming big, that's where you need to use the dependency injection container. If you're just writing a small utility, then don't bother really. You don't need to solve the problem with dependency injection container necessarily. So with container, you can just get, for example, Pimple, because it's easy to read and understand. In that case, configure the parameters, reuse them, configure the services. Also, you can do some additional configuration after the instantiation. You can have some runtime configuration here as well. So this container can help you with various environments. And then really, when you need to instantiate your class, you just tell the container, get me this, this, and that. And I don't care how this graph of objects here is resolved. Just give me these things. I don't want to know what are these dependencies. And also, there is one more thing where container can help you, is that it's managing the lifecycle of objects. So by default, the lifecycle is set to singleton. You can also set it to factory. So every time you need the instance, it just returns a new instance. That's it. So that's where you should use the containers. But really, in which ways you shouldn't use these containers is that you shouldn't use it as a service locator. So service locator is that when you have the container, you have it configured, but actually when you need to use it, you just statically call it and get whatever you need from this. And why is it bad? It's bad from a couple of reasons. You are coupling your code to container, which is okay, we can deal with that. But you are not actually doing the inversion of control, because your module is still responsible for resolving these dependencies. Okay, it's not creating these dependencies, but your code has to know how to call the container, what's the name of this dependency, and how to get it. It's not like, just give me these dependencies. It's like, okay, I know that I have to get these dependencies. So it's still not inverted. And also dependencies are hidden. So basically, you are saying that, okay, I'm doing IoC, but inside, I will just get what I need, and my class potentially has like 15 or 20 dependencies that are hidden, and it's going to be really hard to break in the future. It's harder to test because you need to mock the container, but I think the service locator has one really good use case, which is when you are modernizing the legacy. And you need to, as probably Marek was covering that, you need to incorporate some new functionality. You're writing it in a proper way with container, with injection, and so on. Then we may want to use it, and we actually used it, and it works in that way, because you are not going to replace all the code at one time. So that's how you should and shouldn't use the dependency injection containers. Then we've got the setter injection, which is, in my opinion, one of the worst ideas. It forces you to be really defensive in your code. When the dependency is optional, every time you are using it, you have to check whether this dependency is set, but you don't really care from your module point of view. And the other bad thing about it is that this dependency is not logged. If you can call the setter once, probably you can call it as many times as you like, which means the behavior of your service can change during the runtime, which is bad because it can be really hard to debug later. Also, if something is optional and you don't know whether this code should be executed in your dependency or not, potentially you can replace it with events, as I showed you. There is a logging event. You can just emit this event. And if we actually need to log this, it's going to happen outside of your code. So we can solve this problem of stutter injection and all of those problems, for example, by using the null object pattern, which is quite easy to implement. So this is the good old code with optional dependency of logger. And every time we're calling the logger, we need to check if there is an instance. I know that's not a problem to write this code. You can even generate that. But that's not the point. You should care about the primary responsibility of your class, not some optional things that are going to happen. So instead, you should just inject the logger as you used to do, so that this dependency is always set, and somewhere else, just provide it with an object that does nothing in that case. So in the places where you should be logged, actually you don't care because it's, I don't know, for example, dev environment, you don't need all the logging to happen. Just inject this null logger and it's going to work in exactly the same way, but it's on the configuration level, not on your class level. Okay, so there is one more thing about dependency injection. I told you that the containers are good at resolving big object graphs. There's also other thing of solving exactly the same problem, and it comes from the functional programming. So we have our good old logger, we have this interface and our implementation. And what we are doing with dependency injection, we are injecting logger here, and just erasing here, providing the path. So what we really want to do is we want to call the erase just with the path, not caring about what is the logger. So we are doing this in this way. So every time we're calling this service, we're just providing the path. But in reality, this can be expressed as this function. So it's just an anonymous function in that case that gets the logger, gets the path, and does everything. So it's just basically 4 or 5 lines of code instead of 12 or 15. And what we can do with functional programming is to get this dependency and bind it to this function straight away. So we get our function. There is React PHP written by Igor. You can get this partial and bind the first argument of this function to always be a printing logger. And then you can just pass the function around and call it as you used to call it. So I know that functional programming and passing callbacks in PHP is not so nice because you can't enforce the types of callbacks and return types and so on. But it is a way of solving the same problem. So you can also think about it from a bit different perspective. So that's it about the ways of problems with dependency injection as I see it on a daily basis. But now let's go to the problems, to the real problems that we have with Symfony and with containers. And the first thing that I'm going to discuss is the dependency injection container. So just a quick list of features. We know it supports many configuration files, factories, configurators, and so on. We can also extend it with compiler passes. And it supports lazy loading of services, which is nice. I'm going to cover this in a second. But there is a couple of problems with performance. So what Symfony does in order to make the performance of the container better? The first thing is that container is always getting compiled to pure PHP code. It's not file that is a configuration file or many configuration files parsed every time. It's just one pure PHP file. So it is as fast as it can be in that case. But in debug mode, so in development, it checks every time whether the configurations didn't change. So it takes time. But also, during the compilation phase, some things are getting optimized in line and so on. But the ultimate problem is that large number of configuration files slows the building. Because if you've got really many bundles, it gets slower and slower and slower, because of the compiler process and so on. And that's one of the problems highlighted on Twitter when I asked what are the problems. So how can we address that problem of slow compilation? That one is quite trivial, to minimize number of bundles and config files. But it is important because I've seen a project that had 140 bundles installed. And I tell you that it wasn't a good thing to split and refactor. And basically, you don't need to use Composer and bundles in order to install Twitter Bootstrap to your project. Sorry about that, but it slows you down. So install only what you need. Try avoiding extras like JMSDI extra bundle. I know it's nice. I don't agree with this approach, but the ultimate problem here is that it's going to grab your directories and it's going to be even slower. And all these files problem can be really painful on network file system or on Vagrant and so on. So having many files leads to generating really large container files, the PHP files, and they are getting really slow. So I've seen a container file that was about 8 megabytes of pure PHP code, in a sense that was 8 megabytes text file. So you can imagine it gets a bit of time on every request, load 8 megabytes of file to the memory, parse it, and get everything you need. So that's a problem. So again, remove what you can. But what I suggest in this case is probably if you have so many services that is that big, it's like 8 megs or something like this, probably your application is doing too many things. And if you have, for example, a user-facing application, an admin application, and an API, this could be split into 3 kernels in Symfony so that it gets way smaller. You're only loading the dependencies you need, hence the performance gain. So that's the way of solving that problem. And you don't really need to split it into 3 separate projects. You can keep your structure. You can just add 2 kernels, add cache directories, and it's going to work. And we did that, I think, with guys on the audience that are on the audience. So another myth is about private services in container. That was highlighted by Florian. So private service, you have this flag in container configuration. You can set it as a private. And what it does, it's just a hint for a compiler that probably this service is not going to be fetched directly from the container. And because of that, during compilation phase, it's getting to be inlined, probably. It's not guaranteed. So it gives you just a minor performance boost. But all these private services can still be fetched from your container. And basically, it introduces a problem that people think marking something as a private won't allow other people using your bundles to use these services, and that's not true. This private flag is just for the sake of optimization of container. So you can use it, but you have to know why you're using this. So at the moment, if you are writing a third-party bundle, there is no way to mark a service as a private. That's one of the problems. Okay, another area of things to cover is lazy loading of services. Probably you run into a situation that sometimes instantiation takes lots of time and it uses resources and so on. So sometimes we want to lazy load it. So it is used when the creation of the dependencies is expensive or not needed. So it's the case of the listeners. Most of the listeners, well, some listeners might not be executed on every request, so we don't need to instantiate all the dependencies that may even open connections to some, I don't know, Redis database or whatever. And there are 2 solutions to that problem. You can inject the container directly, or you can use the proxy objects. So I'm going to cover both. So injecting the container is as fast as it can be. There is no faster way of solving that problem, because you are just getting what you need when you need it. But it couples the implementation of the service to your container, which might be might be a bad thing. Maybe it's not necessary because it's coupled anyway, because it's listener probably. But it makes the testing harder because then you need to again mark the container and so on. So the proxy objects were introduced to Symfony. And it's really easy to use because there is just a flag that you set in the configuration, and it works and it generates the proxy object on fly. So your code and your tests are not affected. It works really nice, but it adds a bit of overhead. So every time you're getting this service and calling something on this service, it will be proxied for this object. So if you're calling this some method on object thousands of times, this proxy, you can notice that there is some time that is lost on this proxy call. And also there is an overhead of proxy generation. So every time that proxy is changed and the cache is flashed, it has to be it has to be regenerated. So, basically, I don't think it's warmed up on cache warm up. So you have to check that if it doesn't affect the production after release. Okay, another thing that is not a good practice anymore is defining class names as parameters in your container definition. And it was introduced at the very beginning of Symfony 2 for the reason of replacing the class that will be a service. So, and that's actually a really rare use case, because if you want to change the class, okay, maybe it's going to have the same extent, the original one, but probably you need to change the definition because you are adding some other services that you are using and so on. So that use case is not really useful. So the decoration was introduced in Symfony, so you can decorate services, and defining class names as parameters is not longer required. And in case of Symfony, it was about 300 parameters configured. So you can imagine on generation of the container file, it adds overhead. It just adds lines of code to this container and makes it slower in the long run. And it's going to be removed in Symfony 3.0, so don't do this anymore. The next thing are circular references, which is quite a big problem for some people. That was another thing mentioned by Florian. So what's a circular reference? Most likely, some of you run into a situation that you have the security that gets the user from doctrine. Then you have some doctrine listener that, for example, wants to log who changed this entity. And this listener, because it needs the user, calls the security again. So it's not possible to instantiate this object graph. And how can we deal with this? There are 3 ways of dealing with this. You can inject the container as a constructor dependency, and that's just a workaround because it doesn't solve the problem. Same with setter injection. Again, you can construct the object. It's not in a valid state because it needs a container, so for a short time it's without the container and then it's set, but it's not the solution again. So the real problem here is to solve the design problem. And this design problem, in case of security, was that the token storage service was introduced. So security still is using doctrine to get the user. When it gets this user, it sets into this user to token storage, which is just a state holder in our case. Then the listener gets the current user from token storage, hence the circle is broken, and we don't have this reference anymore. So the problem with your circular references is just with your code, that you are introducing probably state somewhere, and it's just cycling around. So you have to have a look where to solve this problem in your code and where the additional service probably should be introduced. Okay, and another problem is that that's the stateful service here, by the way. Are scopes of the container, and scopes in Symfony, they're present in some other technologies, like in Java. So in Java, you can have more scopes like session and so on, because these processes are long running. So it makes sense there in some cases to have the scope. But in Symfony, it was ultimately introduced to solve the request problem. And the request problem is that one instance of Symfony, one request to the server can handle more than one Symfony request. So we have the main request and the sub requests. And the one instance of the service probably need to interact with request that is the main request and with the sub request. So the first thing was the first implementation of this was to solve it with scopes, but that's not really the good way of solving this problem, because scope means there is a state in application. We are just saying our application is in some state, is handling this request now, or is handling this sub request now. And it leads to problem with injecting request to services, because then you're running into scope widening injection exception. Or I don't know really where this name comes from, but it is an anti-pattern to use request and store request in a service container. It is a service container. It should store services. It's not a value object container, so we shouldn't store it there. Request is a state, and we realized that at some point. that it should be stored somewhere else. This state should be somewhere else. So that was the container that was managing the state, and it was replaced with request stack, so same as token manager. After some time, we realized that the solution was wrong. So with scopes, when something is a request scope, let's say we have two controllers called, and one controller is using the service, and this service had dependency on master request, and the other controller had dependency exactly on the same service, and the same service had dependency on a sub request. So in the old days, what we were doing, we had to create two instances of the same service, even though it's not needed. That's how the scope solves the problem. But with the request stack, what we are really doing is that we have the controllers that are using one instance of the service. This service is using the request stack, which is another service, and we get the state on per need basis. So when we need the request, then we get it and we use it and we forget about it. So that's the way how you should actually write application with Symfony now. You shouldn't inject the request directly, as it's going to be removed in Symfony 3.0. And this leads us to another question, your question about stateful services, introduced by others. So as I said, when you have these services and you need to deal with them, get the state explicitly when you need it. That's the way of dealing with this. But also there is a prototype scope, which is not really a scope. Well, it doesn't solve the scope problem here. So what's the prototype scope? And Christopher said that easy answer is you don't need the prototype scope at all because it doesn't solve the right problem for you. And what prototype scope does, it tells every time I need an instance of some service, create a new instance, and it also propagates to all the other dependencies. So you have 3 instances of service Z, which is stateful, but they are all using stateless service A. But because you set the scope to prototype with flag strict equals true, you're going to have actually 3 instances, while you need only 1. So there was a hack introduced to the scope definition, which was strict equals false, which actually allows that. So what's using prototype with strict false means? It just means we have a factory of new objects that knows to reuse the other objects, how to reuse the other objects. So that's not the good way of solving that. So scope is going to be removed at all from Symfony 3.0 because they don't solve any problems, where the core team didn't find any problem it solves. It just introduces more problems and forces to add more workarounds to the container. So instead, in Symfony 3, you can use the shared equals false flag, which does exactly the same thing. Every time you need a new instance, it creates a new instance and gets the dependencies that it needs without forcing them to be scope prototype. Okay, there was another question asked on Twitter. What about the container-aware interface and when we should extend the base container? So extending the base container has this advantage that newcomers have easier life. They don't need to learn everything straight away, which is good, and I see that is a good point of using this. It limits inheritance, but I don't really care about inheritance anyway. So the problem for me is that it encourages using dependency injection as service locator. As I said, why using it is a bad thing. It is also hard to unit test. So there are 2 alternatives to this. Instead of extending the base controller, we can make our container aware. But still, our controller is coupled to the framework. We don't have these new nice methods anymore. We're still using DECORATOR as service locator, and testing is still hard. So it doesn't really solve anything. Maybe, okay, it solves the inheritance problem. And there is the third option, which is controller as a service. And some people don't like it, but because it requires additional configuration, it makes the development process slower. You don't have these convenience methods anyway, but you can inject what you need specifically to your service, and that's a really important point. Unit testing is easier, so if you are unit testing your controllers, it's doable. And I encourage that because if you do unit test your controllers, it forces you to remove all the complexity somewhere else and deal with this. And it doesn't, if you write a unit test for a controller, you basically can't write shitty code in your controller. And you usually do when you are doing the functional testing or browser testing. You don't care what's there. So that's the valid point for me. And hence the PSR7 is the thing now. It enables you to write framework agnostic controllers. So you can basically get a controller, just accept the PSR7 request and response, and you don't need to actually write a code that is coupled to any frameworks, which is really nice. Okay, and just to say that none of these options is either good or bad, because you can write bad code using the injecting dependencies and using the container as a service thing. You can write a good code extending the base controller. I just want you to be aware what are the trade-offs and where you can use, and it's up to you when you want to use which one. Okay, the last thing that I want to cover in this talk is the event dispatcher component, which I believe in some cases is used in the wrong way. So what's important for me to state, it is an implementation of mediator pattern. It's not an observer. And there are differences, there are like design differences. And you shouldn't think about it as an observer, really. It basically allows you, enables the many-to-many dependencies between objects. And it makes, and that's the primary reason why this is a mediator. It makes your project extensible and allows you to extend other things as well. And also it supports some event flow management. So the problem with event dispatcher that I have and many other people have is that it can be really, really hard to debug and see what's happening there, and when the object is called, when the listener is not, because the propagation was stopped, and so on. So it becomes really hard to debug, especially with managing the flow. And the biggest problem that I have is that events can be mutable, which introduces indirect coupling. And it's also hard to test because you cannot unit test it. You have to usually do some functional test. You have to set up everything, do the configuration, and then you can actually test it. So the indirect coupling problem that I mentioned is that I think it's the easiest way to explain this is an example that we actually had. That on kernel request, we had two listeners, and one was the geo-IP detector that was it was getting the IP and just setting the country code. And the other listener was the local detector that was getting the country code and the user agent, and then just setting the proper locale. The problem with this is that this listener indirectly was relying on the geo-IP detector. So what it was doing, it was relying that the listener that is set somewhere in configuration is going to set the country code in request attributes. And the problem with this is that someone not intentionally can change this configuration for some other reasons, and you're going to spend hours finding why this doesn't work anymore. And also, in reality, what we want to do, we always want to call the geo-IP detection first and then the local detection, and we want to do this in this order. So why don't you just create one class that wraps these two functionalities and just does it at once? It's just going to be way easier. So in reality, what happens with mediator in Symfony when people use it in the wrong way is that our service, some service is throwing an event, then it goes to first listener, does something with this state is coming back. It's not like fire and forget, because this listener is relying on what was returned, not directly. It was returned, it was set on the request object. And it happens, it works like this. So be aware of that, and basically, I don't encourage using dispatcher in that way. So the another question was about when should I use the event system in my bundle. And when you should use it, when you want to extend the Symfony, for example, hook into the request processing, or you are writing third-party bundle that some other people are going to use. So that's the way of providing an extension points. So that's why the mediator is in Symfony in first place. And for your domain events, I think you should consider either creating another instance of dispatcher that is not using the same dispatcher as the Symfony events, or just create an instance of simple observer and just implement your own observer and throw these events there so that you are not coupled to the framework again. So from my point of view, solving the problems with event dispatchers can be real. The way you can solve it is by creating another dispatcher. And basically that's the end, so that's the chapter 4. And just my message to you about the inversion of control is to be pragmatic. If you don't need to use tools like containers, don't use them. Use some other solutions, like for example this function binding, which is really simple to do. And also the second message is to be explicit. It's really really easy to hide these dependencies and just add yet another event, but it's really hard to debug later, and people reading your application can get this right at first, so they're going to spend a lot of time debugging all these problems. And basically that's it. Thank you very much, and I would appreciate the feedback on joining. Thank you.